everybody. It's really good to see you today. This is the first time I've done an address an audience using a silent disco. So please work with me if this doesn't work for you. Stick your hand up and start asking questions. So my name is Tom White. I'm the CEO of SeaCapture. SeaCapture is a startup spin-out from the University of Leeds, based in the north of England. And I am working out how to change slides. So what I really want to talk about today is how the decarbonisation journey of startup technologies needs to use the right kind of investor, the right kind of industrial partners, and the right money at the right time to get across the valley of death. Now, SeaCapture, we're not there yet, but what I'd like to do is tell you the journey we've been on so far. So, what I talk about CCS in general, we're all about industrial decarbonisation. We'll talk about our journey through research and development, through technology proof points, piloting, and then what we need to do next to demonstrate at scale. So CCS isn't for everybody. But what I'd like to do is to lean on an excellent organisation called the Energy Transitions Commission, who put together reports on different parts of the Energy Transition Commission. They put a superb report out called CCUS Vital but Limited. Carbon capture is all about removing carbon dioxide from the atmosphere or industrial flue gases. So SeaCapture is all about the industrial decarbonisation journey. And we're looking at about 8 gigatons of CO2 that needs to be put into carbon capture and storage. But really it's the yellow zone there that 3 or 4 gigatons of CO2 that's pumped into the atmosphere through industrial processes that would still be emitting even if we completed a 100% energy transition to renewable power. This is what SeaCapture does, industrial decarbonisation. So the most important thing is the journey that we're on so far. We started off at the University of Leeds and started off with a partner, IPG. They're a FTSE 500 technology development venture capital fund. And this is Lucy. Lucy studied under our founder, Professor Chris Rayner at the University of Leeds. She's now a senior carbon capture chemist. And what we're doing is building on a very strong industrial heritage in Leeds. CO2 was first discovered in Leeds in 1760 by Joseph Priestley. And University of Leeds has the Joseph Priestley Centre as part of that industrial decarbonisation journey. So from a firm foundation of research and development, we're now moving into the technology itself. So the technology looks just like most carbon capture technology you'll see. You have flue gases going up into the desorber. So flue gases go up the absorber, where our liquid, our proprietary solvent absorbs the CO2, transforms that CO2 into the desorber where it's heated, releasing that CO2. Now this is a very familiar picture to anybody who knows a bit about carbon capture and storage. What's different about this picture is our proprietary solvent. It's the first fundamentally new field of chemistry that's come into CCUS in the last 70 years. It uses a liquid absorbent which has absolutely no amines in it. And that's particularly important when it comes to fugitive emissions which go up into the atmosphere with a flue gas stack. Our solvent is particularly robust, which is very, very important for harsh industrial flue gases with high levels of contaminants which chew through current carbon capture solvents. But the real clincher is the energy saving. The energy saving is between 20 and 40% of leading carbon capture solvents available in the marketplace right now, offered by the leading competitors, which absolutely transforms the carbon capture economics. More on that later. So having come up with the chemistry and the design for the pilot, we then need to build a pilot which will measure attributes of our solvent and how it'll be operating in a continuous recycle phase, gathering the data that we need to design our first commercial demonstration unit. Now, building this piece of apparatus, and it's an overgrown piece of laboratory apparatus, takes 18 months and £3.5 million to build. This kind of journey is not for the faint-hearted, and it's really where we look at large organisations with deeper VC pockets to help us out. Also supported by UK government. So BEIS put in 50% funding for our pilot plant, supported by Drax and BP, who put venture capital funds into sea capture. During COVID, we also introduced the British Business Bank to sea capture's cap table. These long-term, long-hold, patient capital is what you need for the decarbonisation in the climate space, who typically need longer holds and deeper capex requirements. Once we've demonstrated our pilot at 1 tonne per day in a synthetic environment, we then need to get out into the marketplace and prove that our technology works on real-world flue gases in an industrial setting. So there's a big shout out again for the Department of Business, Energy and Net Zero, who are part funding grant programs. But really it's the industrial emitters themselves, and some of them are in the audience today. I can see Heidelberg Cement, Heidelberg Materials here with Hansen, Everose in the waste-to-energy space, Pilkington, as you know, is glass, but also industrial design partners like Wood Group to help us do feasibility studies for how our technology would work in that industrial setting at a commercial stage. And that early deployment is crucial for us to get real-world data back into the design process so that we can then design a full-scale carbon capture plant at commercial scale and commercial implementation. So what does that look like? Again, we'd be looking at government funding, co-funding for our first commercial scale demonstration plant, typically at around that 100 tonne per day scale, which is the entry level commercial scale where our customers are looking at 1,000, 2,000 plus tonnes of capture per day. So we've got our existing investors following through, helping us out. We've got new investors who joined Northern Gritstone with a focus on developing technology in the north of England. But also we're looking for future investors, future emitters who are also looking to go on a decarbonisation journey. So that gives you a feel for what a plant of that scale might look like. But really the message is the right partners at the right time with the right risk capital for the right stage of your development. So research and development, yep, you need a university academic partner with a bit of government. Technology, we're looking at customers. We need a bit of pull here to show that there's customer traction for innovative carbon capture technology. And then piloting. We need to have people who've got the right kind of strategic long-term patient capital to test those ideas with large industrial scale 1 tonne per day pilot rigs. Early adopters, again, we're looking at those industrial partners, space and access to real-world flue gas. And then the next stage is demonstrating at scale. And the real benefit to the UK economy here is if we demonstrate at scale here in the UK, we will have a UK supply chain supporting sea capture's technology here. That's the goal. We've put together a business model that looks at creating a £2 billion a year supply chain in the UK, supplying modular carbon capture plants for the UK initially, and then rolling out abroad. So that really is what I wanted to wrap up with today, and I'd love to take some questions from the audience. Now, I can't hear you, so I'll have to ask for those to be repeated.
Well, if everyone's got the Slido app, using the QR code, you can send some questions through. I haven't seen any questions on the app yet. I don't know if that's because there aren't any or it doesn't work. But in the meantime, I can ask a question then,
please.
Tom, if you can hear me.
Yeah.
So you're talking about bringing in long-term patient capital, and that's very challenging in this market because you've got, interest rates are a lot higher. There's a lot of other places where people want to invest. So how do you attract investors into something like your type of business? And what advice do you have for people who do want to raise financing? Clearly, sitting in Santander as a bank, this is what we live and breathe. But we know it's very challenging to really get running. Yep. So really interested in your recommendations for the crowd around that.
So long-term patient capital is hard. With the stage we're at, we're looking at venture capital investment. Venture capital is typically looking at sort of 5-year exit period, but we need capital for longer than that to build and operate our machines. Similarly, the risk profile. So we need a lot of capital. So putting a lot of capital into one technology for a longer, sort of 5 to 10 year plus. It's really hard. So it's all about getting the mix. Just having VC funds at an early stage I don't think is the answer. I think we need to look at blended capital. So it's government co-funding, it's VC capital, it's looking at long-term strategic investors who want who want to employ your technology, and also long-term finance partners who will be wanting to finance the infrastructure that will be put in place. So it's all about the blend. And I'm afraid there's no easy answers here. We're still having a rough ride.
So we've had a few questions come through now, actually. Now, an inundation. So the first one through was, what more do you need from government?
Right, okay. So our big play with the government right now is all about building a UK supply chain. So what we need is a business model which will enable the first commercial demonstration plants to generate a revenue before the sequestration infrastructure is ready. We need to build a plant now. There are no holes in the ground now. There needs to be something very innovative, very new to sell CO2 into the UK market with some form of modulation to give us a revenue to build our first 100 tonne per day unit in the UK. So that's our number one. It's all about revenues right now.
The next question that came through, what is the next stage and the long-term ambitions for Sea Capture?
So the next stage is to build that first commercial scale plant where we can demonstrate that yes, our technology works at that 100 tonne per day unit. And that's the smallest feasible commercial scale plant, because our ultimate ambition is to take the data from a 100 tonne per day unit and scale that up to 200, 1,000 or 10,000 tonne per day unit, which is what our current long-term strategics are looking for us from.
We've got a question here. What are the capital costs for a 100 tonne per day capture system and the timescales for build?
Right, okay, so capital cost, I love this question. It's a liar's game, really quickly. So, and it all depends on the quality of the CO2 that you've got. If you've got a high percentage of CO2 in your flue gas, like in the cement market, 20, 30, even 40%, then you can use a smaller plant to capture more CO2. Also the pressure. If you've got high pressure CO2, particularly in organisations like anaerobic digestion, then you can operate at 5-10 atmospheres of pressure. So again, you can get a smaller plant capturing a higher amount of CO2. But for a typical 10% CO2 content in a flue gas, 100 tonne per day unit, you're looking about 20 to 30 million pounds for the first of a kind. What we then need to do is to build hundreds of these 100 tonne per day units in a modular automotive style fabrication line to drive down the cost of manufacturing these units. Sea Capture's ambition is to halve the cost of carbon capture by 2030 by a combination of technology, chemical technology and manufacturing expertise, which we want to do here in the UK.
Last question, then we'll move to the next speaker. So is the pilot a catch and release plant, and do you have plans for utilisation in the future projects?
Right, so what Sea Capture is, we are in the capture part, so you have to capture the carbon and sequester the carbon. We're in the capture side of things. So our technology is purely in the capture. We haven't yet developed a solution for utilisation. If there's anybody out there who has got a utilisation technology that I can use today at 100 tonnes a day, please come and speak to me, because I can't wait for holes in the ground. And that will help break the current barriers to success in the commercialisation journey. So yeah, if you've got a large utilisation technology, I'm all ears. Thank you very much indeed for giving me the opportunity to speak today. It's a real honour to be here. Thank you for listening.
Thank you, Tom. Thanks all.